membran fetus ya, kemudian dia menyebabkan abortus pada akhir buntingan ya, dan dia bersifat karir pembawa. Okay.
And for diagnosis, immunohistochemistry and PCR on fetal tissues for single cases is usually good. Also, for whole herd surveillance, there's ELISA.
Ya, jadi untuk diagnosisnya, jadi mereka menggunakan imunohistokimia ya, dan PCR begitu pada jaringan yang terkena, kemudian juga bisa ELISA ya, ELISA.
And I have a story about this. To prevent it, you need good hygiene and to promptly remove fetal membranes. But my story is this. When I was in university, at the University of Minnesota studying for my master's degree, they had a special exhibition called The Miracle of Life, so that they could show children farm animals having babies. My university put a special program showing healthy animals having babies to show children.
Oh, jadi ini programnya apa dari universitas tadi katanya untuk memperlihatkan kayak semacam pameran ya, eksibisi bagaimana memperlihatkan hewan yang sehat begitu ya.
But the problem was at this special exhibition, one of the cattle they had was infected with Q fever, and over 10,000 children touched that cow. So it was a major public health disaster in our state.
Oh, jadi pada saat itu malah ada satu sapi yang terkena itu ya, jadi ini masalah juga ini ya.
And for myself, I don't know if I've been exposed, but I think I've decided when I was preparing for this presentation, I've decided I'm going to go get the test, and if I haven't already become immune, I'm going to get the vaccine.
Jadi kalau ke manusia ya harus divaksinasi tadi karena bersifat carrier-nya itu ya, jadi dia akan ada terus begitu.
And this is another typical finding for Q fever. Weak lambs or stillborn lambs.
Jadi ini tipikal dari apa tadi Coxiella ya, apa Q fever ya. Jadi dia lemah ini ya anaknya, kemudian seperti itu abortus ya.
And this is another slide based on some of my work with Anna from IDvet. So for individuals, of course, you should always check for brucellosis, but then you can do vaginal swabs, and then on those swabs, you can do either individual or a pool of 3 PCR, and then so either quantified or just the reading, the real-time reading strong positive. So 2 negatives, it's not Q fever. 2 positives, it is Q fever. Now, if it's 1 out of 2, you don't know. So you go to the herd, the group, 10 blood samples, and then if the seroprevalence is greater than 50%, yes, Q fever. Less than 50%, you still don't know. So then you do PCR on all new abortions for the next 3 months.
Ya, ini dari alur daripada pemeriksaan tadi dari vaginal swab ya, kemudian saya kira ini dibuat kelompok ya, di pool 3 misalnya. Tapi kalau positif negatif 2 itu berarti tidak terinfeksi, kalau positif 2 positif ya banyak berarti positif ya, Q fever affecting head. Kemudian yang kalau positif 1 ini harus dibalikan lagi ke tes untuk mengambil sampel ya 10 blood sampel yang dilakukan untuk analisis lebih lanjut lagi. Nah kalau dia seroprevalensinya lebih dari 50% ini clinical ya key people, tapi kalau yang kurang dari 50% ini masih uncertain, belum tentu lagi. Itu barangkali teknis ini saya kira ini tiap BVET mestinya seperti itu ini. Atau barangkali juga sudah lebih maju lagi mungkin nanti kalau diskusi barangkali.
And again, I can email you or give you a flash drive with these slides. Too much to write.
It's okay actually. It's very simple, but maybe they have some technical and technical to analyze this.
And so goats is similar to sheep. Some. Okay, similar disease to sheep. I won't repeat what I've already said because it will be the same things, but for different diseases, we hadn't talked about toxoplasma yet. The main thing to remember here is this is the evil one.
Oke, jadi toxoplasma saya kira tahu ini salah satu pembawanya kucing.
So the clinical signs are mummies, abortions, stillbirths, and weak kids. The diagnosis, all these different methods. Again, ELISA, rising titers. You can directly study the fetal tissues, but that's risky because it could be in the environment.
Oke, jadi clinical sign-nya mummies itu. Ya, jadi ini kemudian juga abortus, kemudian tadi stillbirth ya, lahir lemah, dan kemudian diagnosanya tadi dengan apa ELISA ya. ELISA.
In humans, there is treatment possible, but it is so expensive you could never do it for livestock.
Ya, di human bisa di treatment, tapi mahal ya ini. Apalagi diterapkan di hewan ya.
And so good husbandry methods for prevention, feed in troughs, keep your feed stored in closed containers, and control the cat population around your farm.
Ya, jadi yang terbaik adalah mengontrol ya, jadi yang jelas feednya ditutupi supaya kucing tidak ke situ, jadi apa sumber penularan saya kira ya kucing. Jadi kan kalau dengan feednya apa makanannya tertular, kemudian dia dimakan oleh apa kambing ya, dia akan terjadi seperti itu.
And then of course Campylobacter in both sheep and goats causes late-term abortions. It can also cause diarrhea. So the diagnosis is generally isolation from fetal tissues. Fortunately, you can treat and control with oxytetracycline again, so that's cheap and easy.
Oke, jadi Campylobacter ini pada saat kambing dan domba juga kemudian dia apa namanya abortion juga late abortion ya. Kemudian apa diare juga ada, kemudian tadi apa how to diagnose this jadi isolasi dari jaringan apa namanya fetus ya, isolasi bakteri apa namanya penyebabnya.
So now moving into the sort of the last part of my presentation, the question is, when do you start an investigation for an abortion problem? Because sporadic abortions are normal in livestock. So for me, I would say when there are more than 3% abortions in a herd, like in a one breeding season or one calving season, that's for cattle, goats, or sheep. Or if you have a very small scale farm, 2 or 3 abortions in 1 week's time is not normal.
Ya, jadi apa namanya, abortus kejadiannya kalau ini perlu dicurigai gitu ya, kalau memang dia more than 3% abortus ya dalam satu kelompok kan, atau tadi kalau dari small apa namanya farmer gitu ya, periode abortus yang sangat pendek 2 atau 3 kali abortus dalam satu minggu gitu ya, ini harus dicurigai.
So you probably know all of these, being experienced technicians, but the immediate steps to take is to always wear gloves when handling aborted tissues or fluids. Particularly pregnant women and elderly people should really not participate. The risk is just too high.
Oke, jadi saya kira ini apa tahapan-tahapan yang perlu dilakukan ya. Jadi penanganan menggunakan gloves ini, saya kira sekarang di mahasiswa juga sudah pakai gloves gitu, periksa walaupun tidak sensitif katanya mahasiswa. Kemudian apa namanya pregnant woman, jadi orang yang hamil, kemudian ini harusnya tidak berkontak langsung dengan tadi yang abortus itu.
PCR for fluids. For some diseases, it's been verified. For some, not. I think chlamydia and Q fever, I think it's been verified. Otherwise, maybe not reliable.
So we have to have like isolate first PCR for the camelotacta.
Sorry.
You mean if we are going to diagnose the camelotactylosis in sheep or in cattle, so we have to do isolate first from culture?
That would be ideal. You could do PCR as well.
So then I'm asking you, is it possible if you do PCR directly from the fluids or maybe from the aborted fetus, something like that?
Yes, either from the fetal membranes or from the fetus itself.
Yes, possible.
Another pointer, this is from a clinical point of view, this is advice you give on the farm. The animals that are aborting, keep them separate, don't move them between pens, don't let them see pregnant animals, keep them as separate as you can. Number 3 is hygiene. Immediately remove aborted fetuses, fluids, placentas, bury them or burn them. This is really important. People leave that stuff laying around for 2 days and infect their whole herd. And then at that time of year, do not feed animals on the ground. Always use some sort of container, like feeder or trough.
Ya, ini ada beberapa apa namanya step yang harus juga dilakukan ya. Jadi apa namanya pisahkan si hewan tersebut terlebih dahulu, jangan apa bergerak melewati kandang-kandang yang tadi apalagi ada yang bunting segala macam ya. Kemudian jadi abortus yang abortusannya tadi atau cairannya atau plasentanya sebaiknya dibakar atau dikuburkan ya. Kemudian ya jangan memberi makanan kepada apa tanah gitu ya di dasar gitu ya, harusnya ada tempatnya yang khusus gitu ya, sehingga tidak apa ya mudah dilakukan isolasinya penanganannya. Okay.
And so this is the approach I take to investigating a problem on the farm. You gather history, you do an examination of the farm, collect samples, submit them to the lab. The clinician and the lab scientist compile the results, reach a diagnosis, and then give the customer the treatment plan.
Ya, ini adalah sistematika bagaimana apa namanya pendekatan untuk sampai treatment ya. Jadi dari mulai sejarahnya, kemudian pemeriksaan di farm, koleksi sampel, kemudian serahkan ke laboratorium, kemudian Saya kira hasilnya di-compile, kemudian baru melakukan diagnosis dan melakukan treatment dan pencegahan dan sebagainya.
So these are the important questions to ask in the history. Has there been a history of previous abortions? The size of the herd and number of animals at risk? The range of ages of aborting females? Like, for example, is it their first pregnancy? At what stage of gestation is the abortion happening? Is it the first month or the last month? Have there been any animal movements? Did they buy some cattle or sheep? Have they recently handled, for example, vaccination, shearing, or transport? Have they changed the feed source, and have they changed the diet? Of course, vaccination history, and then environmental factors unique to that farm, such as toxic plants, or has there been an unusual weather pattern? And then exposure to other species, you know, pigs, dogs, cats, whatever.
Oke, jadi ini adalah bagaimana mengumpulkan dari sejarah dari petani ya, apakah misalnya sudah pernah abortus sebelumnya, kemudian ukuran dari kelompok dari berapa yang kira-kira memiliki risiko ya ternaknya, kemudian umur saat abortusnya ya berapa ini, tahap keguntingannya juga, kemudian juga apakah ini sudah hewannya sering dipindah-pindahkan gitu. Ini di kita yang paling sering ya, hewannya pindah ke satu nggak ketahuan malah. Jadi kemungkinannya udah ini. Kemudian handling yang baru saja dilakukan, misalnya apakah sudah divaksinasi, kemudian apakah dia baru ditransportasi dari mana ya, kemudian sumber makanan ya, kemudian apakah juga ada perubahan dietnya. Ini yang susah kalau kita mau berubah-ubah terus ya dietnya sapi nggak ini. Kemudian sejarah vaksinasi, kemudian faktor lingkungan, misalnya ada tanaman yang toksik atau udara yang berubah, ya, berubah cuaca dan sebagainya. Kemudian ya, terpapar dengan spesies lainnya tadi seperti babi atau apa, mungkin sumber penularan.
I think people forget to do the investigation themselves, because these are the farmers, and they tell you what they think you want to hear. You really have to go and use your own eyes to see. I'm saying it's important to go do the investigation yourself, because the farmer will only tell you good things. They won't tell you the truth.
Jadi sebaiknya langsung ya untuk investigasi langsung ke petani. Oke.
And this is an important thing for lab diagnosis. People often concentrate so much on the fetus, they forget about the mother. It's really important to do a clinical examination of the females who had the abortion. If you can only do one thing, do a quick exam and take some red top tubes for serology.
So in clinical examination abortus ya, should jadi kadang-kadang kita lupa melihatnya ke misalnya ke feedingnya, tapi padahal induknya yang harus biasanya diperiksa, hewannya bisa diperiksa.
And then for sample collection, this is always challenging, but ideally you would get the fetus, the placenta, and then acute and convalescent sera from the dam. That's the perfect case. But in real life, where people don't have refrigeration or there's no way to get the samples, you can take formalin-fixed samples from the placenta and fetus, or today, now everyone has an iPhone. You can take digital photographs of the placenta, the fetus, and then measure measure the fetus.
Oke, jadi apa namanya, sampel koleksinya dari fetus tadi ya, plasenta ya, kemudian ya apa namanya, untuk best praktisnya saat ini fresh tissue to lab, jadi jaringan yang masih tadi segar ya, sebaiknya segera. Sekarang zaman digital fotografi ya, sebetulnya si petani bisa juga bisa memfoto ya, kemudian dikirimkan, apalagi zaman Indonesia pakai WA segala macam gampang ya. Jadi ukur begitu ya ininya, diukur fetusnya segala macam. Oke.
This is a picture of my technicians in Vietnam, where we had the big problem. That was before the big problem, but we encourage people to always take samples from every abortion.
Ini contoh kasus di Vietnam ya, mengambil sampel. Is it the fetus?
Just looks strange. This is an important point I want to emphasize. Worldwide, the chance of making a definitive diagnosis in ruminant abortion is relatively low.
Ya, jadi apa namanya, menentukan apa diagnosis yang definitif di ruminan ini masih sangat rendah ya.
So you can see UK 2003, only 17% of cases submitted to the veterinary lab had a solution. In 2006, 35%. California Veterinary Diagnostic Lab, 2007, less than 50%. Netherlands, 2012, they had 67% goats and 74% sheep. And those are all cases submitted that included the proper tissue samples. So that's not even including the ones where people sent in bad samples. This is with good samples. It's still very, very difficult to make a definitive diagnosis.
Indonesia even more. We have no data maybe about the percentage of the abortion. Ya, ini datanya beliau bilang ini di luar negeri seperti di tempat-tempat lain ya, terdata 17%, 15%. Di kita sebenarnya lebih parah lagi mungkin ya. Saya nggak yakin, bukan saya menjelekkan negara kita sendiri ya, tapi memang kita jarang terdata kan ya. Berapa persen sih abortus yang terjadi di kita? Kecuali nggak tahu kalau memang Bapak Ibu mungkin di Sulawesi atau di mana itu terdata lebih bagus lagi ya, lebih bagus. Jadi artinya dia mengindikasikan bahwa memang data tentang apa namanya abortus ini apa kejadiannya memang sangat tidak terdata. Apa kalau di kita ini masih mending ya punya data sekian persen segala macam. Ini tantangan buat kita. Okay.
So we hope that we'll be improving. You can see over the years it is generally getting better. Improving from 2003, low, medium, higher. So we hope it's improving.
Ya, dan kira-kira seperti itu, ada perbaikan ke depannya.
And then this is the real heart of the thing. Do you do direct or indirect diagnosis? I would say in general, the preferred method for diagnosis of abortion is direct diagnosis. So that means studying the actual animal that aborted. I mean the actual fetus. And that generally is molecular techniques like PCR, also bacteriology, but PCR would be, the most sensitive, the most specific, but also, of course, the most expensive.
Jadi untuk diagnosisnya bisa langsung dengan melihat dari abortusannya atau fetusnya, atau sebenarnya dengan teknik molekular, tapi PCR misalnya tapi harganya cukup mahal. Jadi ya pilihannya tadi. Jadi jelas kalau ada abortus ketahuan kan, langsung bisa lihat dari fetusnya, bisa juga dengan teknik yang lebih dalam dengan molekuler tadi. Okay.
And then you have to choose which tissue samples do you want to use for your direct diagnosis. The organs from the fetus, they're usually more specific but less sensitive than from the cotyledons. And then you need to be aware of, for different diseases, different organs are best. For example, border disease, the spleen is a good organ to take a sample from.
Ya, jadi untuk mengambil sampelnya tadi bisa organ ya yang dia butuhkan, tetapi tadi organ itu more spesifik, lebih spesifik tapi less sensitif, jadi sensitivitasnya kurang. Jadi untuk border disease.
Border disease is the pestivirus similar to BVD that affects small ruminants.
Jadi ini salah satu jenis penyakit lagi. Jadi misalnya untuk border disease tadi bisa diambil spleen ginjal ya, kemudian toxoplasma ya otaknya.
Placental tissues are often very useful, particularly Salmonella, Chlamydia, Coxiella, that's Q fever. A key thing is you can see macroscopic lesions. You can see something wrong with the placenta on the farm, and that gives you a clue.
Oke, jadi jaringan placenta juga dapat digunakan untuk Salmonella, Chlamydia, kemudian Q fever dari Coxiella ya. Kemudian juga bisa dilihat ada lesio atau kerusakan di secara makroskopisnya bisa dilihat sehingga bisa meneguhkan diagnosanya.
And then more and more vaginal mucus. It's not well understood for all diseases yet, but it's extremely useful for Q fever and chlamydia in small ruminants.
It's okay. Oke, jadi ini belum dimengerti secara mendalam, tetapi ini untuk Q fever dan chlamydia ini bisa digunakan mukus tadi.
And there's people much more qualified than me in this room to talk about molecular methods, but just, of course, there's real-time PCR, and then there's quantitative PCR. In real-time PCR, it's basically yes or no, according to a threshold set by the manufacturer. In quantitative PCR, you can say there's a little infection or a big infection. And for quantitative PCR in small ruminants, it's validated for vaginal mucus and placental cotyledons for Q fever.
Ya, ini kira ini penggunaan PCR ya, ada real time, ada kuantitatif. Yang real time tadi yes or no itu kan ya, nanti pindah ahli